So now we're going to have a look at allowing access outside of the fabric using a firewall. So I've powered on the Palo Alto Firewall, which is connected to our two, which are now our two border leaves 3 and 4. So that is connected on the Palo Alto side, which I'll show in a second, as a port channel. So if I show you on here, we can see it's down at the minute because we haven't configured the ports. But we've got ETH1 and 2. ETH1/1 and ETH1/2, which are configured in this aggregate Ethernet interface, which is down here. And then we can see we've got ETH1/3, which is a, so you could call it a physical interface going out to the internet, and that is actually connected to the internet. So we'll be able to test some web access. We've got this fabric transit address here, which is on VLAN 3260, which has got this address, which is a /29. That's what we're going to use as a transit subnet between the fabric and the firewall. And then this firewall has just got a default route on it that says to get out to the internet, use this ETH1/3 interface. So what we need to do on the fabric side is we need to configure these interfaces into a VPC. On the leaves, we also need to set up a new L3VNI to terminate the SVI for the Palo Alto. So essentially we're going to have IPs on each leaf that match with this subnet range here that we've got. So we'll create a VLAN 3260. That's going to be in its own external VRF, because the idea of this external access is that we're allowing common external access for both of our tenants. If, for example, you just had a requirement for one tenant to have access out to the web or out to their wider network, you would just terminate those SVIs in that tenant VRF, and that would be fine. It would just essentially be an external fabric extension of that tenant. But because in this example we're going to look at allowing access from both of the tenants, we're essentially going to create a third VRF on the border leaves and use that as the termination point for the external traffic. You could use sub-interfaces, layer 3 sub-interfaces, and have those in the tenant VRFs, and essentially have more than just this VLAN on here, and essentially trunk 2 VLANs, one for each tenant, to the firewall. That's a completely valid use case, and I think I showed that in one of the earlier VXLAN videos for external access. So if you wanted to work out how that works and see how that works, I believe there is a video on that. So in this scenario we are going to look at a separate VRF. So essentially on leaves 3 and 4, I believe it's ETH1/8. It is. Let's configure the port channel first anyway. So 1/8. This will be channel group 4. I'll show that. We will create the VLAN 3260. Ooh, that's the wrong VLAN. Get rid of that. And then int PO for switch port mode trunk, switch port trunk allowed VLAN, and we'll just specify that one VLAN. And we'll say this is VPC 4. On leaf 4 we'll do the same thing, so VLAN 3260, ETH1/8, channel group 4 mode active. We'll now shut that interface, and then int PO4 switch port mode trunk, switch port trunk allowed VLAN 3260, and then we'll say this is VPC 4. Hopefully, if we look back on here on the firewall, we refresh this, we'll see that that's now green, and if we hover over here we'll be able to see that the LACP state is enabled and the mode is passive, and we can see our local and partner MAC addresses and priorities. So that looks to be working. If we do a show VPC brief, we'll see that, yeah, that looks good. We can see we've got one active VLAN, status is up, and the consistency is a success between the two VPC members. So now we want to create the external VRF. So because we're creating an external VRF that's going to be used with EVPN, it needs its own L3VNI essentially. So we have to create the VRF, we have to create the an SVI for it, and then we also have to do the whole associate VRF stuff as well. So let's create the VRF first. So again, we're going to do this on both border leaves because we're doing things in VPCs. So VRF context, we'll call this external. We'll set the VNI to 100.555. The RD can be auto. Address family of IPv4 unicast. Root targets. So the root target for both will be auto, and then we'll add eVPN. And we may as well, while we're here, configure the root leaking. So root target import. So we want to import routes from both the tenant VRFs. So 64. 500, 100, 998, and eVPN 100.999 and eVPN. So that's the route leaking part for that VRF done. But what we want to do as well is that's going to pull the routes in from the tenant VRFs into the external VRF. We want to then have the tenant VRFs pull the routes from the external VRF, because we're going to advertise from the firewall using BGP some routes into this external VRF, and we want to pull those out into the tenant VRFs. So VRF context overlay tenant 1 address family of IPv4 unicast, and we want to route target import, and then because we're doing root target auto, it will be 64.500 : and then this VNI. Because there's no eVPN routes in here, in the external VRF, it'll just be IPv4 unicast. We don't need to add the eVPN identifier on there. So do the same for overlay tenant 2, and we're done for the VRF side of things. If we have a quick look, show IP route VRF external, we should see there are some routes in there at the minute because we've just done that leaking, so we can see routes of 10.1 and 10.2. So that's a good sign initially. We won't see anything in the overlay tenant 1 and overlay tenant 2 yet because we haven't configured any BGP routes to be advertised. So what we'll do is we'll just replicate this onto leaf 4. So we'll take all of these actually because it's just the same configuration. There's nothing different between leaf 3 and 4 with this configuration. So it can have all that. And then now effectively we need to add the L3VNI for the external VRF. So VLAN 555. We'll say the VN segment is 100.555, so that matches the VNI that we've set in the route table, which is there. Then we need to create an interface for that, so an SVI for VLAN 555. We will no shut it. We will say it's a member of the VRF external, and then we'll say simply IP forward. And then last thing, interface NVE1, we've got to say member VNI 100.555 associate VRF. That's us telling the VTEP interface that it is an L3VNI. So we will just copy that and remove all the unnecessary bits. It was probably an easier way of doing this. There we go. Right. What's that done? Show run in VLAN 555. It seems to have done it. Interesting. Right, cool. And then essentially that's the L3VNI setup. We now just need to set up this SVI. So this is 10.32.60.3. So leaf 3 will be .1, leaf 4 will be .2. So we just need to configure int VLAN 3260 VRF member is external, IP address is 10.32.60.1/29. No, shut that. We'll say no. IP redirects. And then on leaf 4, int VLAN 3260 VRF member of external, no IP redirects, IP address 10.32.60.2/29. Perfect. What we should be able to do is from each of these leaves ping 10.32.60.3 from the VRF external. Ooh, there's a couple of VRFs with an E in it. There we go. There we go. Just had to no shut the interface on leaf 3, and that's pinging perfectly now. Right, for BGP, I believe it should already be set up on the firewall. Yeah, so we've got a peer group called Fabric that contains leaf 3 and leaf 4, and they're the addresses we've just configured on the leaves. So if we come into router BGP 64500 VRF external, set the neighbor of 10.32.60.3. What was the remote autonomous system of this? 64.520, and then we'll activate the address family of IPv4 unicast, and then we'll do the same on leaf 4. Address family of IPv4 unicast. We should hopefully show BGP VRF external IPv4 unicast summary. Hopefully that should come up shortly. Have a look at leaf 4. You can see that's up, and we can see that's now come up, and we can see that we are already receiving one prefix. So if we get rid of the summary part of that, we can see that we are receiving a default route from 10.32.60.3, and if we have a look at leaf 4 as well, we should see that we're also receiving a default route there as well. We're receiving one from the fabric as well, because the route's going to be advertised up and then back down, so we can there also again see that it's coming from, and that's the best path anyway because it's an eBGP path, but we can see that it's coming from the firewall. If we have a look on the firewall itself in runtime stats, we'll be able to see both peers are established. Our local RIB, we should see that we've got quite a lot of routes in here. So we've got the /16s, the /24s, we've got some /32s, and again /16, /24s, and we've got double the routes because we've got two peers. Looking at the RIB out, we can see that yeah, we're sending a default route to both leaves. So ideally, we don't really need the firewall to have all these /32s. So what we'll do is on the leaves, let's configure a IP prefix list, we'll call it non-host routes, we'll permit 0000/0, and we'll say less than or equal to 31, which will get rid of /32 routes, and then route map, we'll call this deny host routes, permit 10, and we'll match IP address prefix list, and then we'll give it that name. So essentially what we're saying there is we're only going to allow any route as long as the prefix is less than or equal to 31. So 32/32 routes essentially won't be allowed. If you do legitimately have /32 routes in there, you probably can't do this. But in our case, we don't necessarily care about the /32 routes because they're all the host routes, and they're all going to the same place. So it doesn't really make sense to send those to the firewall. So route to BGP 64.500. VRF external neighbor 10.32.60.3 address on the IPv4 unicast, and then we can say route map, we'll call deny host routes, and we'll say outbound. Let's duplicate this config on leaf 3. Match IP address prefix list to BGP 64.500 VRF external neighbor 10.32.60.3 and route map outbound. So if we have a look on the firewall now, hopefully we see less routes. So we've got the /16. I mean, you could go. It depends how far you want to go with removing all the routes. But we can see that now we've got the /16 and the /24. So we've got a route back, or depending on the traffic direction that things are coming, we've got a way to get to the prefixes in the fabric. So let's check on leaf 3 and 4 that we can see this default route. So show IP route VRF. We'll check the external VRF first because that's where it should be coming in locally. We can see that there. And then if we check overlay tenant 1, we should see perfect. We've got a default route there as well, and we can see that it's via the external VRF. We can see that it's been there for 4 minutes, and we can see that from the tag that it originated from AS64.520, which is the autonomous system of the firewall. So if we check in overlay tenant 2 as well, same thing, routes there from the external VRF. We'll just quickly check leaf 4. In fact, I'll have to put it before. There we go. We can see one there and one there. So, question is, do we see this on a standard leaf? Show IP routes VRF overlay tenant 1. And no, we do not. And there's a very specific reason for that, in that we have not told, when we were leaking the routes between external and overlay tenant 1 and external and overlay tenant 2, there's a specific command that we've got to use that allows us to advertise routes that have been imported into a VPN, which essentially eVPN is a VPN. So what we've got to do is on both border leaves, come into the VRF context of overlay tenant 1, and we'll do overlay tenant 2, but under the address family of IPv4 unicast we have to say import VRF advertise VPN. If we come back, yeah, so allow leaked routes to be advertised to VPN. So this is a leaked route because it's come from the external VRF into the overlay tenant VRFs, and that is us saying that we're allowing the leaked routes to be advertised to the VPN, which is essentially eVPN. So we'll tell it we're happy for it to do that. We'll have to do the same on overlay tenant 2, and then we need to also do the same on the other border leaf. So VRF context, if I come out of this, VRF context, overlay tenant 1, address family IPv4 unicast, import VRF, advertise VPN, and the same in tenant 2. What we should see now is where we didn't have a default route. If I do this command again, we now have a default route, and we can see that it's via both border leaves. We can check another leaf, so leaf 5, show IP route VRF overlay tenant 1. Again, we can see that we've got our default route, and the reason we only see it via one path is because we only did the maximum paths addition on leaf 1. If we did the maximum paths config on leaf 5, we would see both border leaves appearing here. So now that we've got that being advertised, what we should be able to do is jump onto a server and ping something out on the internet, and we can. So after a little bit of investigation, this ping seems to be skipping every other ping for some reason, and I've just found that on leaf 4, VLAN 555 is showing hardware program failed. So I think that's just something with my lab. But what I'm going to do is I'm going to remove VLAN 555 and recreate it, and just see if that helps. That's come up now. Yeah, and this ping's now going a lot better than it was. So we do now, if I jump onto another server, so server 6, if I ping 8888, we should see that yes, we are able to get out to the internet. If do I have DNS on here? Ooh. No, nano sudo nano. Let's just quickly set a DNS server here. Quick and dirty. Perfect. So we have got proper internet access, which is a good sign. So we can, in fact, what we can probably do be able to install traceroute. And we can at the very least see, so I'm on VLAN 20, I want to go say to VLAN 10. If I do a traceroute to 10.1.1.1, we'll see now the path. So we can see that we're going to our local gateway, and then our local gateway again, and then the remote gateway, and then the remote endpoint. So there's, essentially we're going from our local leaves to the border leaves, and then to the to leaves 1 and 2, which is where that endpoint lives. If I did 10.1.1.2, we'd expect the trace to be shorter because that host lives on the the border leaves. So that all looks to be working. If we have a look at the monitor tab on the firewall, in fact we can leave that filter in, we can see that stuff's being allowed out towards the internet. So that is effectively, apart from this strange issue where this interface said hardware programming failed, we've now essentially given internet access to the fabric. So there is one other caveat that we need to address. So for example, leaf 3, so say it lost its local connection to the firewall. So is it eth1/8, I think, yeah. Int eth1/8, we'll shut that down, and then we'll show BGP VRF external IPv4 unicast summary. We should see this go down. There we go, that has now dropped. So if we do a show IP routes VRF external, we'll see that we do still have a default route in here, but it's via 10.0.1.4, which is the IP of leaf 4. And if you think about how that would work, we're on leaf 3, we would be going up to one of the spines and then coming back down to leaf 4. And with the way that the VPC secondary address works, that packet will be sourced from leaf 3 but destined for the secondary IP address on the loopback 1 VTEP loopback between leaf 3 and 4, so that's just not going to work. Depending on the hashing that happens, we should find that server 3 VL10 is unable to access certain services on the internet. So if we tried to ping 8888, that looks like it's working. If we tried another IP, might take a few. Yeah, so essentially quad 1 and quad 8 are using the ETH or E1 link going up to leaf 4, which is unaffected because it's still got its connection to the firewall, but 8844 is obviously being hashed up this interface going to leaf 3, which has no real way of getting to the actual internet, because it's going to try and use this route, which isn't going to work. So effectively, there's a reason why this peering has gone down here, that's gone idle, because in theory this is a layer 2, well it's a layer 3 SVI, but it's got a layer 2 connection between the VPC peers using the VPC peer link. And this is where there's a very important thing in the VPC configuration that we need to add to allow layer 3 peerings to run over the peer link. So because this is eBGP, the TTL on the packet that goes out, the BGP packet, will be 1, because it's expected that it's immediately the next hop. We could, if we wanted to, increase that TTL, and that would effectively fix the problem. However, there's a special configuration that we need to do in the VPC configuration that allows when this packet goes through the other VPC node, so leaf 4, it won't decrement the TTL. So if we, just to prove that, if we do a show IP ARP for this, and we just specify external, this is the MAC address of the firewall. If we do a show MAC address table address, we'll see that it knows about this through the VPC peer link. If we looked at this on leaf 4, it would be directly connected down port channel 4. So what leaf 3 is trying to do is it's trying to use a VPC peer link to shuttle the BGP packet across the peer link, and then for leaf 4 to essentially send that to the firewall. But what's happening is leaf 4 is decrementing the TTL, it gets to 0, and it essentially drops the packet. So what we need to do is we need to come under the VPC domain of 200, and we need to enable layer 3 peer router. We need to do that on both leaf 3 and leaf 4. pretty much instantaneously. If we jump back to leaf 3 and look at the peering, we'll see that it's come up and it's been up for 5 seconds. And if we now do a show IP routes VRF external, we'll have our proper default route back. And if we jump back here, we can see that our ping to 8844 has started working. So effectively, because this traffic was going across the peer link and down to the firewall, it was never getting to the firewall because leaf 4 was decrementing the TTL and effectively then dropping the packet because it can't forward a packet that's got a TTL of 0. That is in theory everything to show in this multi-part series. So we've configured everything from the VPC, so the underlay and the overlay, all the multicast side of things, the L3VNIs with both single tenant and multi-tenant, and now we've allowed access outside the fabric. The last thing that we need to do is set up the infra VLANs for the normal VPC, the kind of we'll call it the underlay backup routing path, which it's intended for. So we'll do that in the next video, but for now that's it.